Okay, welcome back. So this section is all about the internet. We're not going to be making websites or doing any web development necessarily, but we're going to write Python code that talks to websites, that gets data from APIs, and builds simple applications using API data. And the way that it will work is that we'll use a package that allows us to make HTTP requests. So pretty exciting stuff. We're continuing on with the theme of taking Python and using an external package to do something more interesting, whether it's printing ASCII art or changing the color of our terminal or getting data from a website. So the way this section will be structured is this video is going to be a crash course on HTTP and how the internet works. So if you've never done web development or you're unfamiliar with how the internet works and what a request and a response is, what an IP address is, what a get versus post request is, if you have any questions about those things I just said, watch this video. But if you've worked with, in JavaScript or in Node or in C or some other language, and you're familiar with making requests and receiving responses, you can move on to the next video where I'll actually show you how to make a request using Python. So 2 paths. Pick the one that's best for you. All right, so let's begin this crash course on HTTP, Hypertext Transfer Protocol. So where do we begin? Well, there's a lot to talk about. Our objectives here are to describe what happens when you type a URL into a URL bar. You hit enter. A lot of stuff happens behind the scenes before we actually get our result. So if I go to google.com, or let's say I search for, salmon, there's a lot of stuff behind the scenes happening for me to see this page here. So we'll discuss that. We want to describe the request response cycle, explain what a request or response header is and give some examples, explain the different categories of response codes, and compare get and post requests. So I should preface all of this by saying you are not going to leave this video being an expert, but you should know enough to understand what's happening when we write Python code that communicates with APIs and websites. But if this stuff interests you, I highly recommend you check out web development with Python, or just web development in general. All right, let's begin. So the internet. Stupid meme, you see the internet. It's like this series of tubes. Very, very funny. When you hear, the internet's a series of tubes, it's definitely kind of a joke at this point. But the sentiment behind it is true. It's just a bunch of computers. The internet is just a bunch of computers that are connected that can talk to one another. So I think people overplay this, internet's a series of tubes joke. But it is true at its core, the sentiment behind it. The internet is a bunch of computers that are all in a network connected by tubes, whether it's fiber optic cable or other wires or cables connecting the computers, or there's some wireless internet in between. Eventually, everything comes down to tubes or cables or wires or whatever you want to call them, and data being transferred. So speaking of data being transferred, when I go to open up Chrome and I type google.com and I hit enter, let's walk through what happens. The very first thing that happens is called DNS lookup. And the next slide will go over that in more detail. But google.com is not, it's not a real thing. Well, it is a thing, but as far as my computer is concerned, it needs to send a request to a particular IP address. So the first step is called DNS lookup. It takes google.com and it actually finds the correct address to send a request to. Then my computer makes a request, an HTTP request, to a server saying, hello, server at google.com. Colt is looking for the homepage of google.com. Can you give it to me? Then the server receives that request and says, oh, okay, this person is looking for google.com. Did they search for something? No? Oh, they just want the regular homepage? All right, send them the homepage. And then the server does just that. It compiles the homepage for me and sends it back. So the last 3 things here is called the request response cycle. A computer sends a request to a server, whether it's your Facebook, your Twitter, Google, any website, Reddit, most of the time for me. We send a request, and then the server sends something back to us. And what's important is, when I searched for salmon here, the exact same process happened. The DNS lookup happened. It figured out how, google.com's IP address, and then the server received my request, but this time my computer or my request said, hey, please give me the page with salmon results. And so the server had to process that request, go find all of the salmon results in the giant Google database, and build me a different web page than if I had just looked for the homepage. But notice, it's the same place I'm sending it to. Google.com is the same first base URL, same domain. It's just that there's all this extra stuff afterwards. And that translates to a different HTTP request. So we'll see more about that. But let's start with a DNS lookup. So it's like a phone book for the internet. A phone book, takes people's names. It's been a long time since I've seen one, but it takes people's names and connects them to phone numbers. This takes domain names, URLs like google.com, and turns it into an IP address. This is what we actually send a request to at the end of the day. This is just a little human-friendly layer. Facebook.com, after I hit enter, I go to facebook.com, I hit enter. Before a request can be sent off, we have to know where to send it. So this might be Facebook's IP address. Same thing with Amazon. There are these unique IP addresses. So let's hone in on this request response cycle. So my computer, which is often called the client, or anyone's computer who is initiating a request, I send a request. And there are different types of request. This is called a GET request. I have a slide on that too. But let's just focus on the IP address. So this is me sending a request to that IP address. And that server processes the request and it does something. Maybe it talks to a database. If I'm going to Facebook, Facebook needs to go to a database and it needs to pull out all my photos and friends and assemble my news feed and then send it back to me. One thing we haven't talked about is how it sends it back, what the format is. Anytime we view a web page, it's in HTML. But we'll also talk about that when we talk about APIs. Okay, so we send a GET request. We'll talk about what GET means. And then the server, assuming everything is fine, sends me the page I'm looking for. But you've probably seen web pages, you try and access a page and you get a 404 error. It says page not found. Or maybe you could get an error that says page has moved, or you don't have permission, forbidden. There's these different status codes. So 200 you probably don't see often because you get a web page and 200 means okay, so there's no reason to display a message to say okay. Unlike, if you get a 404, usually there's a 404 page to tell you something went wrong. But anyway, a server responds with a response. It sends back an HTTP response containing information, a web page, but always a status code to explain how the request was received, if it was okay, or if you're asked for a page you don't have permission to view, or if that page doesn't exist. So the last step, the server sends something back in that response, which is called the response body. And this is HTML. So we're not going to talk about HTML other than the fact that it is what is sent back to your client and rendered in your browser. So if I hit enter again, I'm searching for salmon. I'm going to go to view, developer, view source. This, as soon as it loads, this is the HTML, this massive thing that is sent back from Google's server. So this is what is sent across the tubes in between my computer and Google's server. This is part of the response. And all of it comes to my browser, and the job of my browser is to turn it into this. So every little word you see here, every time it says salmon, every photo is all enclosed or contained in this HTML somewhere. And it looks like a mess because it is a mess. And this is not made for humans to really read. It's made for computers to read. This is made for humans to read. As a side note, if I open Command-Option-J in Chrome, there is a network tab. And this shows me HTTP requests that come and go. And if I make a new request by just hitting enter here, or let me just go to google.com, the main homepage. Watch down here. A lot of stuff happens. But if I scroll up and I click on this one here, google.com, we'll see a status code 200. It was a GET request sent to google.com. And then we could see that we got a response back. And this is our response. This is the page we're seeing right now. So this is just a little developer tool to help people like us who are trying to understand what happened. What's interesting is actually the very first time I sent it, I got a 301 moved permanently. And then I was redirected to 307 internet redirect to this URL. And that's because I just went to google.com, not www.google.com. And so that happens behind the scenes. I'm automatically redirected to www.google.com. But I do remember a time when I was a kid where you had to type that www. Anyways, we're getting sidetracked. All I want to show, we send a request, we get back a response. It technically looks like this. Our browser makes it look like this. Next topic, those requests and responses contain HTTP headers. So headers are sort of like metadata about the request, and they're sent with both requests and responses, and they just provide additional information about the request or response. So the most important thing when I send a request to Google is the URL I'm asking for. Am I asking for google.com, the homepage, or am I asking for google.com/salmon or whatever it is? Am I looking for google.com/news, etc.? And that's important, but there's also other information that I'm sending along, like accept. And accept is my computer's way of saying these are the types of responses that we will accept back. So there are different formats of data. HTML is the one we see in our browser, but there are other formats we'll talk about briefly, including JSON and XML. So for now, I'll just leave it at this, but this is a way of saying I will accept X formats back. There's this other thing called cache control, just another example of a header. It specifies how the caching should behave. There's something called user agent, which contains information about the software used to make the request. So if we actually look at this request, here was the one I sent to google.com. Here are the headers. These are all different headers. So there's the request URL, there's the request method, and then in the response, there are also other type of headers we might get. And I'm not going to go into detail here. I just want to put these here to show you that there's information, metadata sent in a request and then also sent back in a response. But the most important part of a response that we've already talked about are the status codes. So every request we send gets a response. And those responses, if they start with a 2, so there are these 3-digit numbers. If they start with a 2, it means it was a success. If it started with a 3, it means it was a redirect, which we already saw. We got a 307 redirect when I tried to go to google.com without the www. And if it starts with a 4, it means it's a problem on our end. Like we could try and generate one by going to google.com/hello/cult/cat. And there we go. We see a HTML page that says 404, but if I look at the request and then I go to the response, well, not the response body. If we go to headers, there we go. You can see status code is 404. So 404 is the most common 4 error, meaning not found. There's also 500 status codes, which means something went wrong on the server side, meaning that it's not your fault and something happened on the back end somewhere on Google's end, which pretty much would never see from Google these days because that would be disastrous. Okay, so this video is getting long. I'm going to end it here. This is part 1 of the crash course on HTTP requests. The next thing we have to talk about is GET and POST requests and the differences between them, and then also what the heck an API is. So we'll talk about that. So to quickly summarize, I go to a URL, I hit enter. First thing that happens, that URL is turned into an IP address using in the DNS lookup process. Then my computer, the client, makes a request to that IP address with additional information. So it's not just the URL that I'm looking for, if I'm looking for /salmon or /tuna, but it's also who is sending the request, what type of data I'll accept back, and a bunch of other things. Then the server processes it and says, oh, he's looking for the salmon page. Let's build him the salmon page. He wants HTML. Okay, I'll give it to him in HTML. Sends it back to me, gives me a status code along with it that says everything's good, or the page you looked for doesn't exist, something like that. And then my page, my Chrome window, or whatever browser I have, it might be my phone, could be my laptop, will display the resulting HTML it gets back from the response. Whew. Okay,